Okay, so let's use what we've gone over so far to actually answer some questions, the kind of questions that you'll see on the homework. Okay, so here's a case. We're looking at the elongation of steel plates in percentage that are treated with aluminum are expressed in this random PDF. Okay, so we were looking at this specific PDF and we want to find the mean. Okay, I'm just going to use the formula. So the formula for the mean is this guy here. Okay, but I'm missing my bounds. My bounds are negative infinity to infinity. Okay, however, in this case, if you look at the function, and this is going to be the case often, is that we're not actually, the function actually only is defined positively between 20 and 30. So you look over here, you see that this part here, it's 0 everywhere except between 20 and 30. Okay, so when the bounds of your function, or the bounds of when it takes on non-negative values, is not negative infinity to infinity, what we would do is we can just substitute those bounds into here, 20 to 30 of x. And now instead of putting f of x, I'm going to put what f of x equals when it's between 20 and 30, and that is x over 250 dx. Okay, I can do some simple algebra here. I'm just going to, and with some simple algebra, we get x squared over 250 dx. Okay, so now we have an expression in calculus as an integral that we can now calculate. So here's how we're going to calculate it. We're going to skip the actual, those of you who have Calc 2, you should have learned some techniques on how to solve this. It's not too hard. But for those who haven't, I don't have time to teach you calculus, so here's how we're going to do it. I've gone over to Desmos, and I've zoomed in on this part here where you write in the equations, because I'm actually not going to use the graph. I'm just going to use it as a calculator. Now, there's many other ways to calculate integrals with technology. This one, I just like the interface is nice, and the way it writes it is nice. So when I want to do an integral, I just type int, and an integral will pop up. And right away my cursor brings me to the lower bound. So in my problem, I had a lower bound of 20. Now I can use my arrow key, go up, and let's put in the upper bound. The upper bound was 30. And I can arrow key to the right, and I get, I'm inside the integral now, and I'm just going to type the expression that we ended up with, which was x squared, use the caret, divided by 250. And then you need to put this little dx in there to close out the integral, and immediately an answer pops up. Okay, so this is our mean, 25 and a third. Okay, or we can just round it off to 25.3. Okay, so coming back here, we have our answer. It is 25.3. Okay, Okay, now we're going to solve for the variance, and it's going to be very similar. We'll just use the equation, and I'm going to skip one step here, and I'm just going to put in my finite bounds right away. So just like the mean, I already did this with the mean. I can also do it with the variance. Okay, and of course this x in the mean is going to become x squared, and I need my f of x. And as before, my f of x is what is between 20 and 30, which is defined like this. And then don't forget, it's easy to forget, one last step, we're going to subtract this mean. And we already have a value for it, so it's 25.3 squared. Okay, very simple algebra step. In fact, for those who know calculus, and even for those who don't, if you multiply by a constant, in this case, you can think of this as multiplying by 1 over 250. It's very common just to pull this out. So this can also be written like this. Now, don't worry, you can also write this just as x cubed over 250 in here. It's the same thing. They're equivalent. And I'm going to need to find the value of this expression here. So I'm going to go back to Desmos. And most of what I have here is already written. Now, I'll just change this to cubed here. And I will subtract in my 25.3 squared. And there we go. There's our variance. Okay, so note I did write the 1 over 250 here. That's just a habit I have from calculus. You're free to do that, or you're free to leave the 250 in here. Okay, so let's go back here. We've answered another question. And our variance is 9.91. Let's see what's next. Okay, so here we have something new. Cumulative distribution function. Well, that's not a new idea. The cumulative... Okay, well, it's not a new concept, but we just haven't done it with continuous random variables. So the notation stays the same. It's this capital F of x. And it still refers to the probability that your random variable is less than or equal to x. Okay, so this is the same as in the discrete case. However, when we're going to calculate it with a continuous variable, okay, using the calculus notation, we're going to get the integral of the lower bound. Now, the lower bound in general is negative infinity up to x. And so, okay, and then I still am going to use my continuous density function. And I'm going to do one little thing here is I'm going to use a dummy variable. Now, I'm already using x. So for my function, I don't want it. This is a different x. This is, or this is not an x. This is a different variable. It's being substituted here for these bounds. So I did a slight change of variable. It's just a dummy variable, and it's just because x is already being used. That's so I changed it to t. Okay, let's substitute now in our finite bounds. So for this specific function for this problem, we don't actually go down to negative infinity. We only go down to 20. And it's going to be varying up to x. Of f of t now, f of t in this case is going to be t over 250. So the x is changed to a t, but that's just because it's still the same function. It's just a dummy variable. Okay, now I'm going to take a calculus step here. Okay, well, actually, let's just take an algebra step. So similar to before, I can pull out this 250 and it makes my integral look a little bit nicer. Whoops, I messed up over here. Okay, so that's dt. And now I'm going to calculate this integral. For those who don't know, the integral of t is 1/2 t squared. So doing some calculus now. If you're not comfortable with this, you can come ask me and I can give you more details on this step. But for those who've done second semester calculus, this should be clear what I'm doing here. I'm taking this integral. This is the integral of t, the indefinite integral of t, and I'm using these new bounds here. Okay, and when you're calculating this, first of all, I'll pull out this 1/2 and multiply it over here, and I get 500. And then inside here, what I end up with is, first of all, I substitute this x, the upper bound. I get x squared minus, and then secondly, I substitute the lower bound. So it's going to be 20 squared, and let's just jump to 400 right there. Okay, and now note, I did pull this. If you're confused where this 1/2 came out, this came out here and gave me this 1/500. And now I have a full expression for my cumulative distribution. Okay, I think this is a good place to stop. If you have any questions, please stop by through Zoom. I'll be posting regular office hours or just class meeting times. to meet and Zoom. If you have any questions, I'll be also posting some homework, and there'll be some more videos coming shortly. So stay tuned to your email and any announcements.